Welcome to problem session 2. In this session we start with problem number 36. Solve integral 0 to infinity f of x cos omega x dx is equal to 1 minus omega when 0 less than or equal to omega less than or equal to 1, 0 for omega greater than 0. Hence evaluate integral 0 to infinity sin square t by t square dt. So this equation is called an integral equation. We are going to solve this integral equation. Okay, now we look into the left side. Left side of this equation is similar to a familiar transform. If we multiply left side and right side by root of 2 by pi, here we got root of 2 by pi integral 0 to infinity f of x cos omega x dx. This part is called the Fourier cosine transform of f of x. So just by multiplication of this constant root of 2 by pi on both sides, the left side transformed into Fourier cosine transform. Once you have Fourier cosine transform in your hand, just taking inverse Fourier cosine transform, we get f of x. So solution of this integral equation means we find out the unknown function f of x just by using the concept of Fourier cosine transform. We get f of x. So we start with multiplying both sides of the given integral equation by root of 2 by pi and make the left side as Fourier cosine transform. Okay. So when multiply this equation, left side can be written as Fourier cosine transform of omega is equal to right side becomes root of 2 by pi 1 minus omega when 0 less than or equal to omega less than or equal to 1 and 0 when omega greater than 0. So to find f of x back, we just take inverse cosine transform. So by taking inverse Fourier cosine transform, we get left side f of x equal to root of 2 by pi into Fourier cosine transform of omega cos omega x dx. This is the definition of Fourier cosine transform. Now we just substitute Fourier cosine transform of omega from this expression. That is equal to root of 2 by pi integral 0 to 1, because this function is defined with a non-zero value only in the range 0 less than or equal to omega less than or equal to 1. Other part, that is omega greater than 0, it gives 0. That is why we take only the non-zero part of this fc bar of omega. Root of 2 by pi into 1 minus omega, root of 2 by pi into 1 minus omega into cos omega x d omega. Now we integrate this with respect to omega. So I can take this root of 2 by pi outside. So root of 2 by pi into root of 2 by pi, I got 2 by pi. Then I apply integration by parts or Kronecker integration. Here first function is a polynomial of this 1 minus omega. Integration is with respect to omega, so we can use Kronecker integral. So 1 minus omega into integral of the second term. Integral of cos is sin omega x. With respect to omega, the derivative of omega x is x. So sin omega x by x minus derivative of the first term, that is minus 1 into integral of the second term, that is minus cos omega x by x, x into x, x square. Then next term is plus derivative of minus 1 is 0. So this integration is over up to this term. Now we have to put the limit 0 to 1. When I put upper limit 1 minus 1 0 minus, when I put lower limit 0 here, sin 0 is 0. Here we are going to put 0 to omega and therefore sin 0 into x sin 0. So sin 0 is 0, then 0 into 1 is equal to 0. So upper limit minus lower limit 0 minus 0 0. Minus into minus plus into minus minus. So minus 1 by x square into, when we put upper limit cos 1 into x, so cos x minus, when I put lower limit cos 0 into x, that is cos 0 is 1, so cos x minus 1. We multiply this cos x minus 1 by this negative 1, I got 1 minus cos x by x square into 2 by pi. Now I can write 1 minus cos 2 theta by 2 is equal to sin square theta. Here 1 minus cos x, so it can be written as 2 sin square x by 2. See, the result is 1 minus cos 2x can be written as 2 sin square x. Here there is no 2x, so 1 minus cos x can be written as 2 sin square x by 2. Now this 2 into 2 4, so 4 sin square x by 2 by pi into x square. So we got f of x. Now we are going to substitute this f of x here in the given integral equation. Then we simplify this expression, so we could get back our result. Now evaluate the required integral. Let us use the value of f of x in the given integral equation. This is our f of x. When we put f of x equal to 4 sin square x by 2 by pi x square cos pi x square in this expression, we got integral 0 to infinity 4 sin square x by 2 by pi x square into cos omega x dx equal to 1 minus omega in 0 less than or equal to omega less than or equal to 1, 0 when omega greater than 0. So we make some rearrangement. There is a constant 4 by pi. I take this constant 4 by pi from the left side to the right side, becomes pi by 4 into 1 minus omega when 0 less than or equal to omega less than or equal to 1. In the required integral, there is only sin square by x square by some x square expression. So we have to make this cos omega x 1. For that, here integration is with respect to omega. Our x and omega is our parameter. So we can put omega is equal to 0. We cannot put x equal to 0 because this is integration with respect to x, with x varies from 0 to infinity. Just put omega equal to 0. So this cos 0x or cos 0 becomes 1. When I put omega is equal to 0, we have to consider this range 0 less than or equal to omega less than or equal to 1 range contains omega equal to 0. So here we put omega equal to 0, we got the right side is pi by 4. Pi by 4 into 1, pi by 4. Now we make a substitution, put x by 2 is equal to t, so x equal to 2t, so the limit varies from the same range because here the lower limit of x is 0, so when x equal to 0, t is also 0. When upper limit x equal to infinity, t becomes infinity by 2 again infinity. So dx equal to 2 dt. Substitute these limits and transformations in this integral. I got integral 0 to infinity sin square t by x is actually 2t the whole square into dx is 2 dt is equal to pi by 4. When we simplify this expression, the denominator we have 4 2 by 4, that is 1 by 2. Thus 2 goes to the right side, we got pi by 4 into 2, that is pi by 2. So integral 0 to infinity sin square t by t square dt, this is dt is equal to pi by 2. We can replace this t by x, so sin square x by x square dx, or sin square t by t square into dt is equal to pi by 2. So we got the result. Now we move on to next problem. Problem number 37. Find the Fourier transform of f of x equal to mod x in mod x less than 1, 0 for mod x greater than 1. Here we are going to define the Fourier transform, then apply this range. By our definition, Fourier transform is of f of x is f bar of omega is equal to 1 by 2 pi integral 0 to infinity f of x e raised to I omega x dx. So I am using this function f of x equal to mod x. F of x has two values, mod x and 0, and it has non-zero value only in the range mod x less than 1, that is minus 1 less than x less than 1. So I put this x equal to f of x equal to mod x in the range minus 1 to 1, mod x e raised to minus I omega x. We know that mod x is not differentiable and so not integrable, so we split this integral into two parts. Here mod x is based on the value of x. If x is negative, modulus of x is negative. X is positive, modulus of x is positive x. So we can split this integral into two parts. Integral minus 1 to 0, that means negative part plus positive part. In negative part, modulus of x is actually minus x. So integral minus 1 to 0 minus x e raised to minus I omega x dx plus. Now this is positive part. In the positive part, mod x is x itself. So x into e raised to minus I omega x dx into 1 by root of 2 pi pi. Now we can integrate this function. This modulus is eliminated from the scene. Now we just apply Kronecker integration. So 1 by root of 2 pi is a constant. We have to keep it here, 1 by root of 2 pi. We expand this inner expression. So I take this minus outside, minus of first function x into integral of second e raised to minus I omega x by I omega minus derivative of the first function is 1 into integral of this function, that is e raised to minus I omega x by 1 more I minus I omega, that is minus I omega the whole square. Next is plus derivative of this 1 is 0. So this much time is available for substituting limit. When I put lower limit minus 1 and upper limit 0, we can evaluate this integration completely. Applying the same method here, we got first into, that is x into integral of second is e raised to minus I omega x by minus I omega minus derivative of this first is 1 into integral of the second function, that is e raised to minus I omega x by again 1 minus I omega, that is minus of I omega the whole square. Limit varies from 0 to 1, 0 to 1. When we substitute the limit minus of, right, put this minus outside. Here we have 1 by minus I omega is constant, and I put upper limit 0 to x 0 minus lower limit is minus 1, so minus 1 into e raised to minus I omega into minus 1, that is minus 1 e raised to I omega. Then minus into minus I square is minus 1, minus into minus plus, so 1 by omega square is a constant into, and I put upper limit e raised to 0 is 1 minus lower limit minus 1, so e raised to minus I omega into minus 1, so e raised to I omega, plus we do the same thing here but the limit is different, so minus 1 by I omega into, when I put upper limit 1 into e raised to minus I omega minus, when I put lower limit 0 into e raised to 0 1, that is 0 into 1 0, plus here minus I square is minus 1, minus into minus plus, plus 1 by omega square into e raised to minus I omega minus 1. When we simplify this expression, I got 1 by I omega into e raised to I omega minus e raised to minus I omega plus 1 by omega square into e raised to minus I omega minus 1 plus e raised to I omega. But we know that e raised to ix minus e raised to minus ix equal to 2i into sin x. So this expression can be written as 2i sin omega by I omega. Also plus 1 by omega square. Minus 1 is minus 2. E raised to minus I omega plus e raised to I omega. We can use this expression, that is 2 cos x. So here we have 2 cos omega. So 1 by omega square into 2 cos omega minus 2. On simplification, we got this as 2 sin omega by omega plus 2 by omega square into cos omega minus 1. So we got this integration like this. So the final answer is 1 by root of 2 by pi into this expression. 1 by root of 2 by pi, 1 by root of 2 pi into 2 sin omega by omega plus 2 by omega square into cos omega minus 1. Once again, I repeat the result, 1 by root of 2 pi into 2 sin omega by omega plus 2 by omega square into cos omega minus 1. Thank you.